In this section, we're going to talk about mixed conversion problems. So far, we've discussed mole to mole, mass to mass, volume to volume, but by using stoichiometry, which is just a fancy word for the type of math we've been doing, by setting up these brackets and crossing things off and working till we get to the units we want, you can solve for any final unit. So these are the conversion paths you can take. If we have mass and we want to turn it into moles, we divide by the molar mass. If you wanted to go backwards, if you had moles and you wanted to get the mass, well, you'd multiply by the molar mass right off the periodic table. If you had moles and you were trying to get the volume, you'd multiply by the molar volume, 22.4 liters. If you had volume and you were trying to convert to moles, you would divide by 22.4 liters. If you had moles and you wanted to get to molecules or formula units or atoms, you'd multiply by Avogadro's number. But if you had molecules and you were trying to convert to moles, you would divide by Avogadro's number. So if I gave you molecules and was trying to get to mass, you would just have to take this route. We would divide by Avogadro's number and then multiply by the molar mass. Or if I gave you mass and wanted to convert to moles, we would just take this route. We'd first divide by the molar mass and then multiply by the molar volume. Another two-step problem would be going from something like volume to molecules. You would just have to divide by the molar volume and then multiply by Avogadro's number. Or in the other direction, if I gave you molecules and wanted to solve for volume, you would divide by Avogadro's number and then multiply by the molar volume. So you probably don't need to memorize this. It certainly wouldn't be hard if you tried to. You could copy this down and look at it long enough to memorize it. But I'm more of a fan of just setting up the brackets and working at the problem that they have in front of you. And you memorizing these conversion factors, you need to know 22.4 liters per mole, and 1 mole is Avogadro's number of molecules, and 1 mole of any substance is the mass off the periodic table. But just working those brackets until the units cross off above and below and leave you with the unit that they're actually asking you for. So let's do some problems. How much does a billion molecules of iron weigh in grams? So a billion is 1 times 10 to the 9. So we'll have 1 times 10 to the 9 molecules of iron. So we'll set up a bracket. I want molecules to cross off, and we're going to turn it into moles. Remember in our little pathway there, moles were in the middle. It's kind of like the bridge to all the other units. Your first step should always be to convert to moles. So in 1 mole of iron, we have Avogadro's number of atoms of iron, that should say. So then we need to convert from moles of iron into grams of iron. So 1 mole of iron, you just look it up on the periodic table. Iron weighs about 56 grams per mole. So if we write our units as we go, we can cross off and see that atoms of iron cross off with atoms of iron, moles of iron cross off with moles of iron. I'm left with grams of iron, which is what they're asking for. How much does a billion atoms of iron weigh in grams? And if you punch that in your calculator correctly, you'll get 9.3 times 10 to the negative 14 grams. Let's try this one. What would 100 liters of oxygen gas weigh in grams at STP? So we'll start with the 100 liters of O2, and we want to get rid of liters. So remember, there's 22.4 liters of any gas at STP and 1 mole of that gas at STP. And then I want to convert from moles of O2 into grams of O2. So moles will go on the bottom, so moles and moles will cross off, and grams of O2 are going to go on the top. So you need to go to the periodic table and look up the mass of oxygen. Oxygen weighs 16, but in 1 atom of oxygen I have 16 grams, and 1 molecule of O2 I have 2 atoms of oxygen. So 16 plus 16 would be 32 grams of oxygen. So let's cross off our units that cancel. Liters and liters go away. Moles of O2 and moles of O2 go away. I'm left with grams. So I know it's time to get out my calculator and punch it in. 100 divided by 22.4 times 32 grams will equal 142.9 grams of oxygen. So mixed conversion problems are no more difficult than mass to mole or mole to volume. They're just longer. They're going to at least be 2 steps long. Always start with what they give you and set up your first conversion factor to get to moles. This is usually the first step in any multi-step conversion problem. Then you set up another conversion factor to get to the unit they want you to solve for. Pay attention to your units. Cross them off as you go to check yourself. And then multiply by everything on top and divide by everything on the bottom, and you should get the answer correct every time.